Hey, everyone. This is going to be our first video in the quadratic series of videos. So I'm gonna do three videos. This is reviewing quadratic functions, which was chapter 5 in your book. But what I'm gonna try to do is break down this video into three sections. The first section has to do with simplifying radicals. And actually, I'm going to use a different whiteboard over here to explain this. Um, Okay, the first video is going to be on simplifying square roots, or radicals, because with quadratics is squaring stuff, and to solve problems with squaring stuff like x squared equals 30 equals 36, you've got to be able to do what to both sides? Square root both sides. You've got to be able to handle square roots if you're going to use quadratic equations. Once you're squaring stuff, you got to be comfortable squaring rooting stuff. So the first video I'm going to do is going to be on this. The second video will be on all the different ways we solve quadratic equations, and the third video will be on how we graph quadratic equations. There's two main ways. There's like 4 ways we solve quadratic equations. So those videos will probably be longer than this one. So how do we simplify square roots and radicals? The issue with this concept, why we do it, period, is because a lot of times in math, if square rooting was all square rooting perfect squares, if it was all problems like this, then we wouldn't need to do I wouldn't need to do a lesson on simplifying square roots and radicals. It would just be easy. It would just be x equals, in this case, this would be 6. But more often than that, we have problems like x equals the square root of 32, where, it's not a perfect square, but yet we could still make it more simple. Or we'll have something like x equals the square root of 1/2. We have this come up in trigonometry a few times. So what do we do in these cases? And why would this even ever come up in the real world? Well, you might have a field where you know it's a perfect square and the area is 32, and you want to know, well, what is the length and the width? And the answer is the square root of 32. But to explain why, well, let's get into that on the next slide. So if I say the square root of 32, there's basically three deals to simplifying radicals, 3 rules. And the first rule is going to be remove all perfect square factors. Remove all perfect square factors. And that just means that when I have the square root of 32, I have to ask myself, well, what are the perfect square factors? And then I have to ask myself, well, what are the perfect squares? The perfect squares are 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on and so on. So what I do, I know some people prime factor. Prime factoring would be like to do a factor tree on 32 all the way and get it all the way down to every little factor. But I don't like to do this because it's just a little too much work for me. For me, the easiest thing is to just think, let's look over here and say, okay, I want to take the biggest one out of it I can. All right, 36 is too big. 25 is smaller than 32, but it doesn't go in evenly. But 16, does that go in evenly? And if it does, well, then that's going to help me. Because 4 goes into it also, but if I take out 4, I'll have to take out 4 again later. So let me check if 16 goes into 32. This is Desmos. It's a calculator online. 32 divided by 16, 2. Yep, it goes in 2 times. So I'm going to say this is square root of 16 times 2. Then we get to use a rule here. One rule of square roots or of radicals, I think it's the product rule of radicals, is that the square root of 16 times 2 equals the square root of 16 times the square root of 2. I can multiply radicals together like that and factor them like that. And now I get to be get to simplify, because now this square root 16 square root 2 becomes 4 square root of 2. Now, big thing that you guys have to realize, and I maybe should have said this at the start of the video, is that this is a better answer than, a lot of you guys will give me this answer on tests, 5.65 or 5.7. A, you might not have a calculator available, and B, you might have a test that gives you the instruction, answer is in simplest radical form, or answer should be in simplest radical form. And if it's telling you that, then 5.65 is not simplest radical form. So we have to be doing this. And this is simplest radical form because we got now that there's no perfect squares in that radical. So that's one way of simplifying radicals is removing all perfect square factors. The answer should be in simplest radical form. But what about the square root of 1/2, which we had earlier? That was another problem we had, the square root of 1/2. Well, there's no perfect squares in there, but this is another thing, like, we just don't think of it as the simplest form when it's a fraction under a radical sign. I guess I don't have a great explanation for why that is, but we never leave fractions under radical signs and call it simplest form. We say, oh, no, that's not simplest. It's kind of weird, a square root of a fraction. What we like to do is use another rule that lets us do this. So let me write that rule up in our typed deal here. Our second rule is going to be convert all fractions under radical signs using the quotient rule of radicals. I don't care that you remember the title of this rule. I'm just showing that, but I cite it just so that there's some authority and you trust me that, hey, there is such a rule. And the rule states basically that just like when we, on this page, when we multiply two radicals, we get square root of 16 times square root of 2 is square root of 32. Similarly, square root of 16 divided by square root of 2 would equal the square root of 16 over 2. So with radicals, you can divide, if you divide them and multiply them, they work together. You can do that. So that gives me, I've got all the perfect square factors. We got to convert all fractions using the quotient rule of radicals. So I've got my square root of 1/2 to look like square root of 1 over square root of 2. And one of these is a perfect square, right? The top. So that's equal to 1 over the square root of 2. The square root of 1 is 1, because 1 times 1 is 1. But the square root of 2 is not 2, because 2 times 2 is not 2, right? So the square root of 2 is irrational. Now the square root of 2 is simplest form. However, this whole thing is not yet simplest form, and that's because of a third rule of simplifying radicals. And the third rule is simplify all fractions so that their denominators are rational. So in simplest radical form, my denominator is rational. Now, think about this. If I have an irrational number, there's no way, I could just say, oh, well, I'll put it over 1, right? But if it's irrational, there's no way I'll be able to express it as, there's no way I'll be able to get the radical out of the numerator and the denominator. Like, I can't make them both rational because it's an irrational number. And an irrational number cannot be expressed as a fraction of two numbers. Like, this does not equal 7 over 10 or 6 over 9 or anything like that. If it's an irrational number, there's got to be a radical in the numerator or the denominator. So just to be consistent, we decide let's always have the radical in the numerator and not the denominator. Which is to say that down here, this square root of 7 over 1, this is cool. This is simplest form. But this is not. This is not simplest form because we're trying to be consistent. We want our radicals always in the numerator. This is called rationalizing the denominator. And how we do it is we multiply both the top and the bottom by the square root, by the same thing that is on the bottom. Okay, that sounds terrible. Let me try to explain it a little bit better. Square root of 2 is a weird, funky number, and if we want to rationalize it, we have to use the only simple thing we know about it. It's 1.414. I showed it to you over here. It goes on for a long time. 1.412, very complicated number. But if I multiply it by itself, it suddenly becomes less complicated. Now it's just 2. So that's what I'm going to do. I'm going to multiply it by itself. I'm going to multiply that square root of 2 by square root of 2. And I can do that because it's part of a fraction. And any fraction, I can always multiply the top and the bottom by the same thing, and then I will get an equivalent fraction. So square root of 2 times square root of 2, as we said, is 2. Square root of 2 times 1 is square root of 2. And now I have simplest radical form. Okay. One other thing to show you on this video. Actually, I don't think I can do it in this video. I'm probably going to make another video about complex numbers. But for this one, then, let's do one more example. I'll do square root of 7/25. No, that's too easy. Well, we'll do that one first then. So you can always pause the video and try it yourself. But basically I'm going to go, okay, that's the square root of 7 over square root of 25. Now I could multiply top and bottom by square root of 25, but that would be the long way of doing it. What's easier is just realizing, not multiplying it at all, but realizing that the square root of 25 is 5. So the denominator is already rational, and I've got this. Now another example would be square root of 25 over 7. And if I solve that one, that would equal square root of 25 over square root of 7. And that equals 5 over the square root of 7. But now I do have to do that method because I've got an irrational denominator, and that's just not how we roll. So we multiply. This is a complicated number. The only way to simplify it is to multiply it by itself. A mistake a lot of people make is they try to just square the whole thing. They'll say, oh, it's 20, I'm going to times the bottom by square root of 7 and the top by 5. But no, you got to just remember you're really multiplying by 1. So you're going to get 5 square root 7 over 7. And that's your final answer. Can't factor anything. And this video is over.